So I did some modifications a little bit to the game we were playing earlier. I might have moved stuff around a little bit, but this is the board. This is the same thing. 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8. It's the same thing as before. And so now, armed with our new knowledge of squares and square roots in the Bizarro Kingdom, I want to talk about some of these square roots. So here's the square root of 16. And in order to talk about I want a different way of writing square root of 16. There's a few different ways I could, but I want to know how many oranges is the square root of 16. If somebody said, "Hey, will you buy square root of 16 oranges from me?" I'd think they were super weird, but it's a legitimate statement. It's something you can say. So let's find out how much this is, because again, I don't really have a strong grasp in my head of what square roots really mean. So in order to do that, you would find 16 on the board here, and then the question is, what times itself gets you 16? This kind of is a tool that kind of helps us find it. So what times itself gives us 16? And down here at 16, at this 16, we have a 4 times a 4. So the square root of 16, we can say, is another way to write 4. So if somebody says, "Will you buy square root of 16 oranges from me?" I'd give them the amount of money that I think is fair for 4 oranges. Maybe a little less for my trouble and for being a weirdo. That's weirdo tax. You can go back to the weirdo kingdom with that kind of stuff. But let's do another one. So we have the square root of 9. In order to do that, again, you find a 9 on the board and you say, like, what times itself gives you 9. So 3 times 3 gave us 9. And so the square root of 9 is 3. Fantastic. You can kind of see where this is going. We have the square root of 4 here. The square root of 4 says, find 4 on the board. Does that help you find what times itself gives you 4? Yeah, 2 times 2 is 4. So the square root of 4 is 2. It's what row or what column were you in? So then I have this one. The square root of 2. If we're following the same pattern, the thing that I have to do is I have to find the 2 on the board, and then I have to ask what times itself gives me 2. What times itself is 2? And the problem is that we don't have a 2 on the board. So there's another pattern that I'm seeing here that I want to kind of point out to you, is that as you go to the left and as you go up, the numbers get smaller. So 16 to the left of 16 is 12. 12 is smaller than 16, 8 is smaller than 12. It goes up as well. 12 is smaller than 16, 8 is smaller than 12. Remember, this is the math that we're doing here. 9 smaller than 12, 6 is smaller than 9. This pattern holds the whole way through the board. Anytime you walk to the left or anytime you walk up, you're getting smaller. Every number that you see is bigger than 2, so maybe the board's just not big enough. Maybe we need to expand it a little bit. And put the 1s here. And so now we got to set up the board a little bit more. We have to fill out these blank squares here. So 1 times, well, let's talk about 1 times 1. Is that a square? Is 1 times 1 a square number? We have 16, 9, and 4. Here are the squares. 1 times 1 is a square number. So we'll say that's a 1. Here are our squares, 1, 4, 9, and 16. Okay. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. You see that we said the same thing even though we went across a row and down a column. Maybe there's a pattern there. Maybe there's some fancy property we'd use for that. So now, let's go back to the original question. It was, what's the square root of 2? We got to find a 2 on the board and then ask what times itself gives us 2. So here's a 2 down here. Square root of 2. What times itself gives us this 2? Well, this 2 is a result of multiplying 2 and 1. So nothing times itself gave us 2 here. And nothing times itself gave us 2 in this one either. It's also 2 times 1 over here as well. In addition to that, we have this steady decreasing squares up here. So we have 16 and 9 and 4 and 1. 16 is bigger than 9, which is bigger than 4, which is bigger than 1. And we went from 4 to 1 and we didn't say 2 in between. So what is the square root of 2? What times itself gives us 2? And the answer is not nothing. This is a number. Something times itself would give us 2. And I encourage you to put it into your calculator, partially because I didn't write it down. But what you'll find is that we have 1 times 1, which is 1. And then 1 times 2, which is 2. So 1 times 1 is 1. 2 times 2 is 4. The square root of 2 has to be smaller than 2. Something times itself gives us 2. It has to be between here somewhere. If you put it in your calculator, you'll find that it's 1 point something crazy. 1 point something, 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 something forever. If we were to try to write that number down, we would either have to cut off at some point, 1 point something, 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 something. We'd either have to cut it off and then lose the rest of that number, or we'd have to keep writing forever and we would never stop and we would grow old and die. And the only thing we'd ever be writing are all the digits to the square root of 2. And what a legacy that would leave behind. The square root of 2 is a number out there. It's a quantity. It's a number of oranges. It's something bigger than one. It's more than 1 orange and smaller than 2 oranges. It's somewhere in between there. It is a number, but in order for us to most accurately talk about it, we can just leave it as square root of 2. Look at that. 2 strokes of the marker, and we already have this infinitely long number that would have taken us years and years and years and years and a very sad legacy in order to fully write, and we never would have finished. But we could just write square root of 2, and we would still have all of the accuracy of that number because it does exist. It just exists in this form. How many oranges do you want to buy? Do you want to buy square root of 2 oranges? That's more than an orange and less than 2 oranges. It's some amount of oranges. So for that reason, if somebody sells you not 1 square root of 2 oranges, but 2 square root of 2 oranges, that's 2 times square root of 2 oranges, they're going to give you slightly more than 2 oranges, but still less than 3 oranges. You can write something like this and say it's 2 times the square root of 2, and that is a number. That's a number of oranges that you can buy from some weirdo salesman. So sometimes it's a lot easier to say 4 than it is to say square root of 16, but this is still a number. Other times it's a lot easier to say square root of 2 instead of 1 point something, 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 especially when it's 2 times the square root of 2 and not 2 times 1 point something, 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 something. Sometimes we like this. Sometimes we like this. Sometimes we like a word. Sometimes we like a number of fingers. Sometimes we like division. It's all just describing numbers. It is every single post-it that you see is a quantity. It is a number of oranges. Never lose sight of that and detach yourself from the idea that anytime you see these operators, what you're doing is math instead of just describing a quantity.